Welcome to Pure Physics. Today we're going to see chapter number 2, Kinematics of class 11, Physics Tamil Nadu Board. Today's topic is vector algebra, and under vector algebra we're going to learn about scalar quantity and vector quantity. So what is scalar quantity? Quantities that can be described only by magnitude is called as scalar quantity. For example, distance, mass, temperature, time, all are scalar quantity because it does not gives us the direction of the quantity. It only gives us the value of that quantity. So those are all called as scalar quantity. And vector quantities are the quantities that can be described by both magnitude as well as the direction. And for example, displacement, velocity, etc. Because in displacement we see about the distance covered and the initial point and the final point, because displacement is defined as the difference between the final position and the initial position of an object. Now we are going to see the types of vector. So before moving on to this types of vector, let me tell you the general representation of vector is an arrow mark in which this part is called as the head and this part is called as the tail. Now I need to tell you what is the magnitude of this vector. So consider this as vector A. This is A vector and I need to find the magnitude of vector A. So I am drawing the same vector A vector here. To find the magnitude, it is nothing but the length of this vector. The length of the vector is known as the magnitude of the vector, and it is denoted by the symbol modulus A vector, or it is simply represented as A. So this is called, the length of the vector is called as magnitude of the vector. Now moving on to the types of vector. So we have equal vector, collinear vector, parallel vector and anti-parallel vector. So first we will learn about equal vector. Equal vector has three conditions. Now let us take two vectors, A vector and B vector. A vector and B vector. Now I need to prove these two vectors to be equal vector. So in order to prove that, we need to see the three conditions. One, it should have equal magnitude. What is magnitude? Length of the vector. Therefore, the length of these two vectors should be equal. If it is equal, the first condition satisfies. Then it should have this, both the vectors should move in the same direction, which is happening here because A vector and B vector are moving. And then you need to ensure that it represents same physical quantity. If these three conditions are satisfied within these two vectors, then we can say the vector A and vector B are equal vector. Now moving on to collinear vector. Vector acting along same line is called as collinear vector, and that is the angle between the two vectors should be either 0 or 180 degree. What is this angle between two vectors? Now you know that this is the tail part of the vector and this is the head part of the vector. Let me take two vectors. This is vector A and this is vector B. Now the head of the two vectors will not touch each other, but the tail of the two vectors will touch each other and make an angle theta. Make an angle theta, which will give you an angle, let me say, in this condition, the angle between these two vectors should be either 0 or 0 degree or 180 degree. When the 0 degree and 180 degree will happen, and what is the name of that condition when these two angles are formed? That is nothing but parallel vector and anti-parallel vector. When do you call two vectors parallel vector? If the two vectors act along the same line or on a parallel line along the same direction, then it is called as parallel vector. So there are two conditions. If the two vectors act along same direction on same line or on parallel line. So for same line, we are going to take in one line consideration, and we are going to put two vectors along one line. So that is, the black line is the first A vector, and on that black line there is another line which is called as B vector. So here the angle formation is 0 degree. So these two vectors are parallel to each other. On the other hand, we have two vectors, A vector and B vector. they are moving in same direction, but they are on parallel lines. So they make angle theta is equal to 0 degree. Therefore this case is also a parallel vector case. Now moving on to anti-parallel vector. So when two vectors act along same line or parallel line but acting along opposite direction, then it is called as anti-parallel vector. So there, in that case also we have two types of cases. One is along the same line and along the parallel lines. If I take two vectors moving in opposite direction, B vector is moving towards my right and the A vector is moving towards my left. So there the angle formation is 180 degree. So it is an anti-parallel vector. Here the A vector is moving towards my left and B vector is moving towards my right along parallel lines. Therefore they are anti-parallel where the angle is 180 degree. And now we'll move on to the unit vector. What is unit vector? If we consider a vector A vector, and now we need to find the unit vector of that vector, then we need to divide the vector by its magnitude. We need to find the length of the vector and then divide the vector using that length of the vector. That is, in order to find the unit vector, you're gonna just write the A vector and divide it by the length of that A vector. That will give you unit vector and it is denoted as A cap or A hat. Now we are going to see about orthogonal vector. So let me consider I cap, j cap and k cap. These three vectors are called as unit vectors, and I cap represents for the positive x-axis and j cap represents for positive y-axis and k cap represents positive z-axis. So these are unit vectors, and all these unit vectors are mutually perpendicular to each other. So when do they call vectors as orthogonal vector is when two vectors are mutually perpendicular to each other, they are called as orthogonal vectors. So here the j cap and k cap are mutually perpendicular to mutually perpendicular to each other, which is 90 degree. And here I cap and k cap are also mutually perpendicular, and here I cap and j cap are also mutually perpendicular, which has 90 degrees. Therefore all these three vectors are mutually perpendicular to each other, and therefore they are called as orthogonal vector. So in our next video, we'll be learning about the topic called as addition of two vectors. Thank you.